My name is Cohen with the Buck Barbecue, and today I want to discuss reasons as to why I think basic ass TA is garbage. I wanted to first state that this is entirely my opinion, so therefore it's not necessarily a fact. I am just merely presenting a different way to view just a data set. Furthermore, because as to why I use basic ass versus just regular TA is because I recognize also that the more advanced techniques used by experts don't necessarily fall into this overrealization. I also am not a public speaker, so therefore I'm probably going to fuck this up a lot, but I'm going to see what fucking happens. So I thought the first thing to do is to define definitions. Well, those two were in the same sentence. Anyways. So, definitions of stats and TA. So, pulling off the Googles. Statistic is the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a representative sample. TA is defined as the financial analysis that uses patterns in market data to identify trends and make predictions. So that's pretty solid and pretty basic. We define some shit. Technically, it's official shit. Alright. So, because not many people are used to doing data analysis, I thought it would be a good idea to define types of variables. Anyways, so when you look at any type of system that has like numbers or categories or whatever the fuck you want, there will be overall a potential of two different types of variables. The first one is qualitative word. The other one is quantitative. Anyways, I can't write. I'm sorry about that. But again, I just want to state how my computer's over there, and I made a bunch of like notes and general like outlines so I don't like get too distracted and also maintain the point I was trying to make. So a qualitative variable essentially is anything that's not quantitative. Okay, what does that mean? So basically, a variable that does not use numbers. Hooray! What does quantitative do? The exact opposite. A variable that uses numbers. Alright. Let's see. So, I guess going on top of that, the primary difference between another difference between qualitative and quantitative is that qualitative data lacks specific or any type of measurement. So fun word, the study of measurement is called metrology. There's a bunch of engineers that focus on this shit because sometimes it's fucking hella important. All right, what are different types of qualitative data? So there are, within these two different variables, there are more different variables that are subsections. One of them for qualitative is called nominal, which is just a fancy fucking word for name. The other is ordinal, which essentially means order. So some examples of nominal data is the name of a stock ticker that's being analyzed, or the color of eyes, or anything that gives a name and uses characters versus actual numbers. Ordinal is order. So essentially it's like small, medium, large, or anything like that. There's a series of orders where it's not it doesn't use numbers. However, it is not nominal because there's like someone like order for them. Anyways, whatever, fuck it. That was to fuck it. All right. Another form of qualitative data is basically feelings, your emotions and such like that, because it does not have a solid form of measurement, and so therefore, nor is it a number, so therefore it can't be quantitative. This is important for later. So going into quantitative, that uses numbers. There are two different types of numbers. We have our discrete, and we have our continuous. So discrete data are values that have a hard stop. They are not any number between negative infinity to positive infinity. This essentially is like your counting data. Counting data. And continuous is essentially like variables where it could be like any number between 1 and 2. And when I say any number between 1 and 2, so oh my gosh, I have chronic hiccup, so I apologize. So let's see, we have 1, 2, 3, 4, 5, and whatever. Series, check that. Because there are hard stops between these values, it is 1 or 2 or 3 or 4 or 5. It is discrete. In comparison to continuous, so basically, continuous is basically, any number, literally any number, no matter the decimal point, that exists between whatever range you define. So it could be like 1.000299420 69 and whatever. Or it can go up to like 5.1 or whatever have you. So essentially, continuous variables literally is any number that exists within the range of like my 1.002942069 or my 5.1. Just using, like, I guess we should have a 6. 1 through 6 as our defined domain. Domain is a fancy word for basically what the fuck numbers we're going to be looking at. Anyways, let's get rid of that shit. Dope. Let's see what else I got. So, going back into TA versus stats. So, as said earlier, TA looks into the financial analysis to identify patterns and crap like that. It also attempts to measure the immeasurable. This means feelings. Feelings. Whoa, feelings. So the most common type of feelings people talk about when it comes to TA is fear. Oh shit, my water. And greed. These both are qualitative data. The reason as to why the fear and greed are qualitative data is because they lack a form of measurement. Essentially, like, how do you define how much fear is in the system? How much do you define greed? There's no basically like, how much does the smile weigh? Or like, what is the like overall like celebration of like disappointment? Dun dun dun. There's no measurement, and furthermore, like what I think is fear and greed is going to differ from someone else. So it's subjective as well. There's no good form of measurement because it's qualitative and TA uses it. So, what else? Hold on a second. So also TA incorporates So the problem with TA is because it tends to use these kind of variables in order to determine the share price and time, like the time frame in which it's going to happen, there's a problem with that. So if you have some magical box where you have the input variables, some shit happens here, and then you get the output. One argument that's somewhat confusing, people don't know if share price determines the emotions or vice versa. So due to the lack of discrepancy or even overall just like determination of where the fuck that goes, so this could be feelings and share price. And so therefore, this is also feelings and share price because who you're talking with is going to be entirely subjective. Share price. So this presents a concern. So since you don't know which one controls the other and vice versa, you can't necessarily define what your input and output variables are. It could be intermixed, it could be the other way around. This creates some confusion or problems when you're trying to use one or the other to determine like share price when they occur at a specific timeline, because depending on who you talk with, it could be one or the other. So that's problematic. Also, generally speaking, going back to our dope ass box, if your output variable is continuous, output, continuous, there's probably going to be an input variable that's also continuous as well. So this essentially is discussing your input and output variables are going to be the same, overall the same. So continuous, discrete, qualitative, nominal, ordinal, or whatever have you. The general idea is because, for example, you have your sweet x and your function of x. Function of x right here is essentially a fancy term for y. Why, oh, y? Anyways. So let's say your x exists within like range between anywhere between, like, I don't know, -10 to 10, because that's pretty easy to understand. So the reason as to why, like the input variable for this example, we'll use a continuous factor is this value exists whatever you want. So therefore your x value, since I guess that would be -10 and that would be +10, like every single value between -10 to +10 is going to have like a y, depending on whatever function of x is. So if you work, so the function of like the result, so the result would have a sorry about this. Let me drink some water. So since you can't have effectively any number between these two, y, like the y or f of x is going to have any value of x. So it would have like -9.999 42069, and then like +9.99 42069, and any like literally any number. So it's therefore like there's no types of data transformations which would basically result in a discrete value. It's like where the hell you want to use. Because any number between x is going to be used, therefore any number between wherever the fuck that is going to be used. It exists on a continuous scale. Another point is like if you were to have discrete, so So that's your y. Maybe I should probably make that bigger. So if you were to use a discrete variable to define your inputs and outputs, we'll just use -10. So x exists within the range of basically -10 to 10. So we got -10, -9, -8, blah, 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 to positive 8, 9, 10. So when it comes to a discrete variable, it won't have any numbers between -10 and -9. It won't have -9.99 or like -9.01 because there's a hard stop that exists here. It's your counting data. So because you have a hard stop that exists here, when you go back to your x, yeah. So we have our function of x is equal to whatever crap. So because these values have hard stops, whatever function of x is going to also have these hard stops. Because the x value will not have a decimal point, essentially. So there will be these jumps in a way. So we'll have like this, maybe that to that. Versus continual will have like this overall type data. This is all, like, I should state also that all of this is like a huge generalization, but I wanted to make this simple as fuck because there's no reason to overcomplicate this shit. Okay, what else was I going to talk about? So one thing I've noticed when a lot of people do TA analysis is always a type of hindsight that's being used. What I mean by that is the multiple different types of formations, however, after the fact, people are like, oh, I mean, I could totally see why this is a head and shoulders, or I could totally see why this is that after. And so when people make fun of like, the share price is going to go up, down, like, or sideways, yes, but the way that it does so is going to differ. So I pulled some shit off the internet to basically like provide examples as to why that people are like, this is hindsight type shit. So like a double top, that could be dirty. Anyways, so a double top has this like overall type value. See how there are double tops? Like there's two maxes and then it goes back down. All right, so if basically you have this x, which would be your time, and then y would be your share price. And so as time continues on, we'll just continue this double top. It goes like this. However, because share price can go up, down, sideways, or whatevs, so while some people are like, oh yeah, it's totally going to make this M-type shape, however, it could also be like this. And so after the fact, when people thought it was going to be a double top, however, they were incorrect because the share price can literally go any fucking way, so it decided to go up. So it's not until after the fact, after you see the share price, do you actually know what type of shape is actually being created. That's one reason as to why I personally think a lot of TA is incorrect, because you don't know what's going to happen. So a double top, to effectively further explain as to why people don't necessarily know what the hell's going to happen, is a lot of hindsight type crap. So funny enough, a double top although it can be like this, can also be a head and shoulders. So these are 3 different maximums that occur at a different time. And the only thing that differs is between this and that are the number of peaks. So instead of basically the double top that goes straight down, it instead hits another top and goes up. You may or may not be able to predict that until after it's done. But these two type of formations share a lot of commonalities. But it's all about whether or not it goes up, down, or sideways. Here's another example of basically how the share price behavior may differ from what you think is going to happen. So if you have basically your, I realize after draw was bigger, so your time function and your share price. I'm going to use like a favorite fucking formation people use. Anyways, so there is something called a rounding bottom, which basically is right here. I mean, it's the bottom and it's fucking round. All right, cool. And then it goes to a reversal upward trend. That's pretty cool. It's pretty simple. The reason that's to a reversal upward trend is while this one is going down, is being negative, it hits the rounded bottom, it reverses, and then it becomes a positive trend. That's pretty simple. But if the share price decides to be like, no, F you, we're gonna do this cup and handle. So everyone loves the couple handle. So instead of having this continuous movement in the positive Y direction versus moving downwards, it decides to do a downward shape overall. So this is your cup. There's your little cup, and this is your handle. These differ because the share price can go up, down, or sometimes even sideways. So, I mean, it's a lot of hindsight. These type of formations are very similar, and it's difficult very often to know whether one is going to happen over the other. I mean, people are like, oh, this is totally going to be like a wedge, and then after it happens, like, oh, how did it, and obviously, in hindsight, was this. So, there's a lot of overall shapes that are similar to one another. However, because the share price can go up, down, or sideways, who really fucking knows? They'll be all the same. So we can also talk about wedges. So let's say you have your head and shoulders and whatever. So another thing that I'm pretty fucking looking for is like these wedge type shapes. So one thing you also have to be wary about is not only these very different kind of maxes, but also the oscillations that occur. All right, that's cool. Then of course you have your negative, whatever. So one thing, they're like, oh, we're going to break the triangle, whatever, and it goes up, cool. Or we're going to break the triangle, whatever, and it goes down. I mean, there are various different indicators to know which way over the other, but I'm merely stressing the point how the overall share price can go up, down, sideways, wherever the hell. Keep. Oh, and then so basically this one's going up, that one's going down, and don't forget like the pendant. because it's a cute little thing. So it goes up and then smaller, then smaller and smaller. This is your sideways trading, or your bull flag. Ugh. Yep. Up, down, sideways. All of which are Hindsight, and all also have various smaller kinds of just like formations within it. So not only is like looking at the far view, the macro view, anyways, view of this, where it has this overall shape that could be continually oscillating, it will also have this overall like shape that determines the overall share price or trend. All right. Oh, and it gets even better. So let me first define how fucking candlesticks work. So you have your general candlestick, and I don't have a green marker, so this is gonna be your green. Or this is gonna be your red candlestick. I do have red. Red candlestick, and it goes like this. And then you also have your black. So the bodies of these candlesticks are going to be dependent on whether it's a green or a red or black, whatever. So for a green candlestick, the edges of this wick are going to represent your highs and your low. So, but however, the body for a green, this is going to be the value it opens at, and because it's green, this is going to be the close. For a green value, your close is greater than your open. So it goes up. For a red, it shares the same locations of the highs and lows. So this is your high, this is your low. However, the actual beginning and end of the body of the candle is going to differ. Because it's going down, because it's red, the open value is going to be greater than the close. So in comparison with the close greater than the open, because we're going up, it's a positive movement. Here, we're going down. It's a negative movement. So this way, your close is less than your open. So I should state this is a negative change, this is a positive change. And then we have these completely like black bars. What this means is your close is equal to your open. There was no change in the positive direction, nor was there change in the negative direction. While we still have the same highs and lows, the open and close is the same because there's no overall range, there's no difference enough. There's no difference between the open and close, therefore we have this type of crap. Anyways, so with that more or less defined, so, oh man, okay. So candlestick measurements are and range from anywhere from like 1 minute to like whatever the hell you want to use. Why is this important? So different times, like time frames of these candlesticks can show different types of movement. Within multiple TA books, they will suggest to use 1 minute candles essentially if you see a volatile ticker or any, but if it seems like really slow as fuck, you don't really care about the data so much. But so therefore I might even use like 1 month. This is purely for examples, it's not for necessarily like how it should be taken. So for a 1 minute candle, anyways, it could be showing like this kind of behavior, and it could be moving up. However, if you were to take an outward looking view of it, it might perchance tell a different story. So the 1 month value is overall looking at the positive or negative, similar to the 1 minute candle. However, it says the difference between the high, open, high, low, closed between the beginning of month A to the end of month A. Beginning, end. So depending on what type of candlestick time frame, these overall shapes or these overall trends might be different. And so if you have this 1 month data, you don't necessarily view how it changes over time, because it could be lower, closer, or whatever. So for example, if we have month beginning, then month end, it could just be, oh, if you look at a series of months, oh, it looked like it's going down. However, if we were to look at the minute candle, because perchance this particular ticker is extremely volatile, so it's like going all over the place. So it's going to be up, or like, oh, this type of stuff. So while we have this, be able to view this type of macro trend, it does not necessarily show the substituents within it to tell you what it's doing on a regular basis. Again, this is all dependent on the volatility of the ticker itself. So one thing that's very common within TA, not necessarily all of it, but one thing I've noticed as well is that when looking at these different time frames, the majority of people, see, this is green. So your high, low, open, close. They only necessarily observe the closing value, which is upsetting because these type of shapes shows 4 different variables, and by only choosing one, you're not necessarily getting the high, close, open, low. So you're missing out on a lot of potential data that's given to you, but the majority of the way that this system is often very used is just looking at the closing data, which again is a shame because there's so much different information that is given. Let me think for a second. Oh, so in regards to what I was stating earlier, versus the discrete versus continuous stuff, and why the need when you have this system, a system where it has an input value to output value. We'll make this input is, input output. When it comes to these type of formations, it has a very hard stop. And what I mean by that is, I guess looking at GameStop because everyone loves it, personally me too. If you were there since the beginning, since January, this is something I noticed. So we have our initial squeeze, whatever, this. So at that time, people were still assuming, or just basically placing lines that would allow these type of cycles to fit in it. However, because a multitude of people, or even when they perform this, do not necessarily use all the potential data of the high, like close, open, low. Within these, you'll see like individual candlesticks that existed outside of the formation itself. So while the share price, in a way, is overall continuous, variable because it can range from anywhere to 0 to positive infinity, these type of very discrete hard lines are not the appropriate way to describe this type of distribution. So let's just talk about types of distributions. So a bell curve, also known as a normal distribution, or if you're fancy, a Gaussian, something that people are very familiar with, has this shape where it's symmetrical around the y-axis. So this point right here is your mu. Mu is a fancy little symbol to represent your average. Because this is a symmetrical value or symmetrical distribution, I mean, people are pretty familiar with like this type, because it's like everywhere, not all the more fancy shit. Here, for a symmetrical distribution, our average is going to be equal to our median. I need some water, give me a second. So the median value or variable is like the middle number. Kind of looks like median middle. So if you have this perfectly symmetrical value, the middle number is going to be right here. Because, for example, we have our 10 to negative 10, and like the same number of like samples are within here, and the same number of examples are within here. Thus, our median is equal to our average. In comparison, but there are types of, there are also something called a skewed distribution. I should probably keep that up. What do I mean by skewed? So instead of having this very lovely symmetry, it has this type of value like that. Here, a median would be here, since it has the most overall samples that exist within the average itself. So this is basically any value x, and this is the frequency of that specific value. It's, I mean, just for example. And so the majority of values are going to exist right here. So because the majority of values exist right here, the middle number is going to basically the high probability going to be right here. However, so here, because it's skewed, there's going to be your average, or your mu, is going to be greater than your median. This is because this value could be like positive 100, and this value could just be 10. So it goes up into in whatever fucking number, and this pulls away from the median. It doesn't necessarily show you how the actual skewed data is. So one primary example of this is when people, or the US stats, whatever type of stats people, use the median value to say the median household in the US is about 50 G's, and they don't do the average, because we have our gazillionaires that have all this money that has that goes off the board. These gazillionaires are going to cause a overall cause a shift in the average. So also another nice thing to note is there is this limit right here where essentially this frequency or this type of skew data does not go. It doesn't have this continuous type like that, but it goes right here. There's a limit. There's a hard stop. So this is, just to remind myself, so this here is going to be your mu is going to be greater than your median. I need to remind myself. So that is, let me think. Yeah. So sorry about this. I haven't taken like this type of stats class in like 5 others, so therefore I forgot like the technical terms and I need to sometimes remind myself. So this is called like a right skewed or positive skewed data. Oh my gosh. Skewed. Because these large values over here are pulling the average value further away from the mean. On the other side, I guess we might have to delete this. We make it smaller and cleaner. So just to reiterate, the first type of distribution where it's symmetrical around the y-axis. This is your typical bell curve. Bell curve. It is also called a normal curve. Or dash distribution, dist, whatever. But if you're fancy, it's also called Gaussian. Probably going Gauss. See. And anyways, so it has these values that is symmetrical around the y-axis, and it's going to have like this. This is where our average is equal to our median. Since the number of samples that exist here are going to be the same number of samples that exist here. They're going to be even, so therefore one particular large value isn't going to pull it one way or the other. It's pretty even. So then, as I previously discussed, the right or positive skewed just like distribution. This is where our mean or average, I guess I should maintain my variable terms. So let me do that for age of simplicity. Our average is greater than our median. Again, the hard stop and its tail that goes that way. So this is where our median would be. And an average would be over here. Because the larger values are causing a skew from the median, and there is this hard stop, so there's nothing on the opposite side that would even this side, like that would basically null out the larger values. So unlike here, where the smaller values or smaller number of values, like the frequency, how often like over here occurs, is going to be the same as over here. However, because there's a limit, that is not the case on this side because they're absolutely jack shit that's occurring over here. So counter opposite to like the right and positive, it's like exactly an opposite. So we have left skewed, which is a negative skew. This is where our average is going to be less than our median. It has the opposite direction, where we have this mean, and there goes the right tail. So our median is probably around here, while our mean is over here. So this is our median number, because the same number, the same amount of, or I guess the same population or the number of samples that exist here are going to be similar to the number here. So the actual count data is going to be the same. So like count over here is going to be like the same count over here because we have our median value. But if you look at the actual value of the count value, like the count numbers, it would show that because there is a hard stop here, you can't have anything that would directly counteract this value over here. All right. So I think this pretty much like describes the overall like type of 3 general distribution types. All 3 of these define a continuous type of variable. There are different types of distributions outside of this normal curve right here, and you determine which distribution you want to use dependent on how the output variable looks like. So I mean if it's like uniform, it would look like this. Whatever, Gaussian will look like this. So you determine the type of distribution in order to accurately describe where the fuck you're looking at, dependent on the type of variables you're observing. So there's a bunch of different distributions depending on like, oh, this is nominal or ordinal, or like this is quantitative or qualitative, whatever. So there's more than just one type of distribution. So let's go back to normal and the, hold on a second. I want to discuss more about the normal term. So if we have a mean, and so one, like if you go through a lot of the indicators or different types of general ways that TA, that's a really garbage type, like it's like attempts to analyze the data, it will show that, actually one, it very often uses the mean and this thing called the standard deviation. So what's the standard deviation? So the standard deviation basically tells you like how wide the spread is. So something that has a very small standard deviation, so small SD is going to have a very high peak in comparison like that with this mean right here. A large standard deviation is going to have like this type thing where it's very spread out on a, so the standard deviation is an important, like another important value that you want to pay attention to. So we have all these means and whatever. Means, means, means. So one thing about the average or mean, just looking at it on just calculating type shit, like -1 and 1 are going to have the same average as -100 and one positive 100. They're both of their means are going to be equal to 0. So that's when you want to understand or look into this overall spread of the data distributions themselves. Ugh, talking too much. So a quick guess and check is that the standard deviation exists at the inflection point. What the fuck's an inflection point? So the inflection point is essentially where the concave down moves into concave up, or concave up goes to concave down. Concave up makes a cup. Concave down makes a frown. And so for this particular thing, the inflection point would be probably right here, if I were to guess. So right here would be one standard deviation from the mean. So this variable right here is called sigma, and this is the typical variable that is used instead of just writing standard deviation. This is mu for average, this is sigma for the standard deviation. So with the standard deviation that's used so conveniently right here, and how this is symmetrical overall, the standard deviation is going to exist at the same location right here. However, this is a negative sigma because we're moving in the other direction versus positive, we're going that way, and they both exist at the inflection point. So something very nice about this, given how it's a very symmetrical distribution, we can take this back. So the distance between the next standard deviation is going to be equal from here to here. So that is probably right here. So that's going to be a plus 2 sigma. So it's right here, so it's going to be over here. So this is like a negative 2 sigma. And so the majority of data, when people look at you, is plus or minus 3 sigma. Anything above that is like super a lot of accuracy. So we'll just make the positive 3 sigma, and we'll have the negative 3 sigma. So this exists a really nifty rule called the 68, 95, 90.7 rule. What that basically means is, so the amount of data that exists within mu plus or minus 1 standard deviation, so solely this area right here, is going to have 68% of the entire population or entire data set. So this is going to be 68% of the data is going to exist between mean and plus or minus sigma. And so then we got 68, 95. So 95 is that 95% of the data is going to exist between mean and plus or minus 2 sigma. So this is our 68, this is our 95, and because it's called the 68, 95, 90, 99.7 rule, within 3 sigma, with all this stuff, mu plus or minus 3 sigma, over here, it's going to be exist your 99.7 of the data. It will exist between your average plus or minus 3 sigma. Pretty nifty trick, and this is all because this is symmetrical around the y-axis or just around the mean. Let me double check my notes. I guess I'll continue this general mindset. So I like to use Bollinger Bands to describe how the use of mu plus or minus 2 sigma, which is 95% of the data, is not the appropriate distribution to use in a share price. So when I talk about you use the type of distribution that describes the overall behavior, this is a good example. Ow. So this is our time, this is our share price. So, I don't know, we'll have these type of candles if you go into the Bollinger Band specifically. One thing that it uses is something called the moving average. The moving average is, instead of they're looking at everything and then calculating the average of everything, it chooses a value, or it chooses basically how far back you want to add to the overall average. So for example, since I'm using 5, so we'll use like, I don't know, let's just say those are minutes, why not? I like using 5-minute moving average. So it's gonna take this value, because that's 5, and like basically the last 4 values and then calculate the average of what this is. And so when the next value continues on, so this is our 6th value, it's going to take the other 4 to recalculate the moving average. So as time continues, the average starts to shift depending on the number of samples you want. I mean, this is all the number of days or minutes or whatever have you that you want in a moving average is, again, I guess I shouldn't say again, is going to be subjective. So for a type of ticker that is extremely volatile, you're going to want to view the moving average at a smaller rate than something that's pretty lame as fuck, or you might want to use a larger value just to better understand. So the moving average is really good for any process or system that has a lot of variability. We'll make this really big because I'm beginning to understand how big this kind of needs to be. So we have our time and our dollar bill, y'all. All right. So we'll have maybe this moving average that like maybe it's like super volatile as heck, and it's like, oh shit, fuck you, and it goes down to here and maybe goes up to here and whatever. So using a smaller like moving or like number of whatever unit there, like the unit of time you want to use, it will reduce the noise in the system. So instead of looking at actual values, we'll say these are like green, and this is, yeah, it's going to be negative, I think, whatever, I don't even know, it's a green, whatever, another green. So typically the moving average looks at the closed value. So here, open, close, whatever, these examples. But I mean, it doesn't have to be green or like red, whatever. But the point being is that instead of looking at every single value, it's going to reduce the noise because it's going to look at, if we continue our 5 data, like our 5 day or whatever, our 5 count, like moving average, it's going to take the average of what this crap is, and essentially it's going to like cancel out each other. So although there might be this extreme volatility, the average might go this and right here, because something large like this is going to very much like kind of counteract or null out this type of value. So it's good for watching something that has a lot of volatility. In my engineering experience, I use something like this when like there is like too much shit and there's just too much noise. For example, like we'll have like this and it goes like, and so you want to understand the inherent behavior that exists within the system. So instead of like doing this, because it's all over the fucking place, it'll smooth it out so that it shows the inherent shape of what this is. This allows you to, I mean, it simplifies the data and becomes like more easily to find out what the fuck is actually going on, because sometimes too much noise makes it difficult to determine what the fuck's going on. All right. So now that we overall define what moving average is, I want to remind people about the normal Gaussian type curves. So just a side note, like we have our this, we have our this, and then we have our this. Anyways. Oh my god. Okay. Oh my god. Anyways. So, very similar to what I was talking about with the moving average. Bollinger Bands take the moving average and then also calculates the distribution of this. So if you have basically, it's like the frequency, it's count data. So we have maybe like a bunch, so if maybe this is like, I don't know, $1 and this is like, I don't know, $100. Maybe you have a very high value here, over here, and then you have some onesie, twosies type stuff right here. So the standard deviation is not used for something that has a skewed distribution. The standard deviation is only used to describe a normal or Gaussian type curve, something that is symmetrical, because the standard deviation is located at these inflection points. And it follows the 68, then, which is here, the 95, and then a 99.7. This rule cannot be applied to something like this, because although the inflection point may be here, there is no equivalent type of shape that exists right here. There exists a limit. So you can't define the other side of this distribution, because the shape that determines what the standard deviation does not exist in this area. So when the data is skewed like this, the more appropriate way to essentially define the statistical characteristics within this is going to be your median and your range. The median value is used because maybe there exists a very large, since this is left skewed, negative value, negative value. So negative 100. This will cause the mean to be pushed further that way. And so if you have some sort of median value, median that exists right here, depending on, the convexity or concavity, where the hell you want, because your mean is going to basically push the average that way. Maybe instead of having 100 as a max, it uses negative 50. So something like that would have this higher curve here because the average is smaller and thus pushing, not necessarily pushing the average further out. This is why, as I said previously, the median household for the US, whatever, is like this amount, because the gazillionaires are going to skew the data and they won't necessarily represent accurately what the average the median salary is for the US household is. I hope I described that pretty well. The same idea for skewed data also exists on the other side. You don't want to use the mean because it's not directly representative of the majority of the data which exists here, because this is a count data. So the median is more accurate to describe, because the median describes the majority of the data that exists within this bell curve. The majority of people have this. But however, if you were to use the average, it would skew the data, so then it would suggest as a result that the actual median or the actual typical household has a lot more fucking bougie ass money than what it actually does. So in a system or distribution that is not symmetrical, like this, you should really use the median or the range, because the average may pull away the overall data, thus not representing in the distribution correctly, because I mean, negative 100 and 100 have the same average as negative 1 and 1. So this is why looking at the spread is important, and also what you use to define the spread as well. So skewed data uses median and range, because it tells you how long, like basically how big the max and min is. That's why it uses range, because there's no clear way to use a standard deviation, because you don't know where 68% of the data is, or 95 or 99.7. There are different type of ways to do this, but whatever, that's other stats that don't necessarily need to go into. So as I was talking about the Bollinger Bands and its use of the min, like the average, along with actually plus or minus 2 standard deviations. Let's say just, I don't feel like drawing the fucking candlesticks. Actually, I should actually draw the candlesticks. So, so you'll have like, I don't know, I'll just draw a bunch of crap. This is your time, whatever definition you want to use. This is your share price. So again, I guess the mean or your moving average is first going to be determined by whatever number you want to use that looks at the previous shit. So let's just make up this imaginary type scenario where the moving average maybe does this. It'll go up to here, and then it won't be so low, and then maybe go like this. So this is, I don't know, a 6-day moving, 6 minute, 6 day, whatever you want, moving average. So with Bollinger Bands, we also incorporate the plus or minus 2 sigma to define these shapes that are typically colored in blue or some sort of lighter blue, like that. In regards to the share price itself, it is inherently skewed. This is because the share price cannot drop below 0. It does not have a negative value. So in regards to relating this to a skewed data set, so this is going to be our $0 price, $0. And this is going to be the frequency at which whatever the share price actually, like a specific share price exists. The value cannot drop behind the $0. So therefore it's going to inherently have a skewed data where it's going to be like this and right here. Because of this limit right here. So our median, because it's more appropriate to use the median and range for a skewed data set than it is to use the mean, because a single mean value can easily push the data or moving average in a direction that does not necessarily show where the fuck's going on. So in regards to this, so while these may be a small overall like size of candlesticks, something like this that's really big is going to throw everything off. So this is like an example of how the mean is going to pull, like the actual, like the mean is going to pull away from what this median value is. So you would have like not, it wouldn't be a good characteristic to find what the fuck's going on. because although the mean's over here, it doesn't matter because the majority of the data exists here. So that's one thing about how a lot of TA uses averages, but this is not a good metric to define something like this that has a limit at 0, because it is not a normal distribution. Something like this that exists much more than 2 standard deviations above this moving average is going to skew the moving average for quite some time. So therefore, we don't actually understand what the share price is doing. There are different ways that are like, oh, if the majority of data is going like above this, then it's going to do whatever. So this is where the standard deviation comes into, or the 68, 95, 99.7 rule. So this is our inflection point. So from here to here, which is mu plus sigma, that's negative sigma, because these distances are the same. That's probably about 2 sigma, positive 2 sigma. It's probably about positive 3 sigma, and we'll go on the other side, make that prettier, where this is about negative 2 sigma, and this is about negative 3 sigma. So mu plus or minus 1 sigma is going to have 68% of the population. It's a count data, it's frequency. So 68% of the population is going to exist within this value. And then mu plus or minus 2 sigma is going to have 95% of the data exist between here and here. And then mu, which is a fancy select variable for average, plus or minus 3 sigma, sigma being standard deviation, is going to hold 99.7% of the data set. Incorporating this value, which is the 2 sigma, that very often is used to define these Bollinger Bands. 95% of the data, by definition, needs to be between this moving average and these shaded areas. What a lot of times will occur is because it uses average versus the median, because it's a skewed data set, and therefore mean is not the correct metric to use to describe this. A lot of the data may be like this. Like above or below these Bollinger Bands. And since the moving average, basically -1 and +1 have the same average as -100 to 100, it's going to null each other out. And so within, not only is it using mean when it should be using median because the value exists at a limit, using the 2 standard deviation does not abide to the 95% rule. Because whatever number of values are up here, I mean, for this particular sample, would, I don't know, we'll just say 10. 2 out of 10 of the data set exist around outside about this. So therefore, by definition, we know it is not a bell curve because it does not apply to this rule, and yes, it's called a fucking rule. So therefore, using not only the mean, which it does, but also the standard deviation. So therefore, the better way to view it is the range. So maybe if you have like, the median value is right here, whatever. So therefore, you have the range of the view. So you actually understand maybe this is a small range, and all of a sudden there's a big jump in the range. So using range will allow you to actually view like huge outliers that exist above these 2 Bollinger Bands, And that, using the range, is far more, I guess, it tells more of a story in regards to what the system actually is behaving. Because, I mean, you can't use average because it's skewed. You don't understand the entire overall, like, how that distribution has actually happened because there's a bias pulling it away. And because it doesn't appropriately uses the standard deviation, we don't get the full story. Like this, I mean right here, because we're using what, 2 out of 10, so therefore only 80% of the data exists here. It does not follow this rule that is defined by the Gaussian curve. However, the majority of TA that you observe is going to use that. It's going to use the mean and standard deviation. Something to pay attention to. It's not necessarily, it is not the correct metric for this type of distribution. This is a very common reason as to why a lot of TA doesn't get the shit right. I need some water. Let's check my notes. I don't want any more water. I gotta go missing. Do. All right. Those are my notes. So, I say the word so too much, but it's kind of like my thoughts or whatever. Another thing about TA, it tries to attempt to use, emotions as a metric in order to guesstimate what the share price is and when it's going to happen. A lot of the times in order to do this, it only looks at the most recent data without necessarily using the entire time frame of data. For example, let's think of, I don't know, so GameStop is a prime example of this. So in 2021, we had this dope ass squeeze and then all this shit happened. And because of TA only looks at the most recent data, it was only looking at, anything positive 2021. It did not, people weren't necessarily thinking about what the fuck was going on in 2020. So comparing that to stats, in stats there is no such thing as too much data. Well, that's my opinion. People might disagree with that, but that's my opinion because you always look at the data and be like, this is fucking irrelevant, and then not worry about it. So looking at this, a lot of people are drawing these dope ass pendants, just focusing on the 2021 data, not focus on the 2020 because it was really just like this whole black thing. In regards to using data analysis, it uses as much fucking data as they'll use. So GME began in 2002. However, people kind of assumed that this very small, pre-2021 share price was flat. And this assumption occurred due to data formations or data formatting. So if we were to look at the pre-2021 data, pre-2021, we would also see these continuations of cycles. Although it wasn't so obvious because the actual values between these highs and lows weren't as big of a range, however, they did occur. So it would be like this. So looking into typical DA, it only looks at the most recent data and uses that to make a general assumption about how the vibe of the share price is looking at. Because they're not worried about something that occurred this far, because it's unlikely that someone would have the same feelings here versus over here. Like they're just saying overall that investing, they're only interested in like the last 90 days maximum, then people start to lose interest. Data analysis, or regular stats, is going to look at everything because it looks at the actual raw data. So a lot of basic as TA, it only uses visual graphs. It doesn't actually determine what the fuck is going on. They don't look at, very often there is no polling of data, there's an analysis of actual raw data. There is creation of purely just what they think is going on. Just whatever formation you have, although there is like values up here and here. So it's kind of funny, like the number of times, like, oh yeah, like it's going here. So there's a logarithmic like minimum right here for people assuming that like exactly on this date it's going to shoot out. But something that we kind of see is that no, that's not the case. We see these cycles that continue on. And so even in the beginning when people are like, oh, it's going to shoot out here, this same type of technique is even used to this day. So they just extend these type of formations out relative to wherever we are in the current time frame and share price. People have been doing this, like it's the most bullish like type pendant since like 5 ever. In order like they mean like it's observational bias. And observational bias is a killer because you're drawing whatever you want. They're using a discrete like go no, this is your go no zone. A discrete like type of I guess characteristic to define what the overall behavior of it is. This has a lot of like observational data, not only because of that, but it is very superficial. So when I say that, it only looks at this. It only looks at share price in relative time. However, there are a multitude of different variables that actually can affect a system like this. This is called a multivariate system. Multivariate means multiple variables. So if you were to actually pull like raw data, you'd be able to see, like although this is like really, really small in comparison to this crap that goes off that way, you'll be able to actually see how something like this shows how it might be related to volume, for example. So instead of looking at share price versus time, you have another factor or another variable to describe this type of system, which would be volume. So in comparison to here, which is a visual representation, very superficial without thoroughly describing the system itself. For example, here you have a better insight of what's going on because it'll tell you, like the majority of people like were doing shit on this day or that day or whatever. Depending on how thorough or the type of system you have, there could be a shit ton or there could be like very few, but nonetheless. So data analysis looks at all these different type of variables that may essentially influence the system itself and figures out there's something called regression, which ones are actually like influential to the system or not, and we go from there. Oh. Let's see. So let's discuss the benefits of looking into other variables that would, in theory, affect the overall share price. So we have this very commonly occurring type pendant that's happening. This is observational bias because people are drawing the lines wherever they want without using any set of like a defined area where it makes sense for these lines to draw. Instead, they're just kind of drawing lines that make sense to them. But if you just draw lines that make sense to you, as previously spoken, it could just do like this, or it could do like this, depending on how. So this goes back into hindsight type like discussion, or this could be like a double toe, or this could be like head and shoulders, but without actually viewing, like doing the raw analysis of the data itself. People are assuming that, oh, this is like this shape, it describes the entire system. Another common thing I've heard very frequently is people talk about their favorite formation, and one thing is like, oh, this particular formation can be applied everywhere. That is somewhat concerning because not every distribution is going to be the same. So if you're like, oh, I love the pendant, it can be located anywhere. It's like, oh, whatever. So people are like, oh, it's a repetition of shapes themselves. People are like, oh, this describes all the systems and such like that. But in order to actually confidently determine one sample, like this population here, is equivalent to the other, you have to use regression. Regression is a fancy term by basically using mathematics to determine correlation in shape. So without essentially using the raw data, these types of lines are all due to observational data, like observational bias, which is further exacerbated by determining like basically what someone sees versus someone else. For a newbie type TA person, they might see different formation between one or another because it's all superficial. They only look at the share price without necessarily performing the actual analysis between here. And because the commonality of various different formations or that are talked about, a greater amount of formations are going to be more occurring because people are like, oh yeah, I really like how this fucking shit is acting like this fucking shit. But without regression, you cannot confidently conclude that they actually are. You need to perform the actual math to calculate how much this shit actually is equivalent to that shit. Because without actually calculating it, you're just fucking guessing. And not to mention how dependent on your time frame when this occurs, this shape may be different. I don't know if it's like we use the 1 minute for this, like this overall shape may be different, or at this time frame, the shape might be different versus like, I don't know, a 30-minute. So not only will you have observational data depending on what the fuck you like, but what you view and how you view the data might be different at these different time intervals. Like very frequently, like when I was reading these books, I know, I wish I could read, very frequently within these types of a volatile system, books be like, oh, you want to go through, you want to look at both 1 minute and 5 minute to actually get a better idea of what the system is, or if it's like really like calm as fuck, you want to use bigger ones. That's all personal choice. So that's shitty. So there's no, yes, it doesn't use concrete values that define the system itself well. It just offers suggestions on various different numbers that you think, oh, like, well, I prefer looking at this and that, or I prefer looking at this and that. And although they're like, oh, the general type of rule of thumb is 1 in 5 minutes, it's not going to be the same from ticker to ticker because each one has a different amount of volatility. And so we can have like, talking about an ordinal, like we have a shit ton of volatility here, like a medium amount here, and a small amount of this. Ordinal. And so, I mean, this is like seeing a lot of shit, pull back a little bit, maybe it's not like seeing as much volatility, and then this one has absolutely fucking nothing. I mean, this is another example about how different people will view the data at different time frames, and by preferences, I mean, they'll use different type of formations or indicators that they think describes the data set well. But without concrete numbers, it is all observational bias. Concrete numbers tell you everything. It tells you the overall distribution of the data, but within here, they very commonly use mean. However, that is not a good metric for these type of this type of distribution, because it is skewed. So therefore, the mean is not the accurate measurement to look at this, nor is necessarily the moving average, because it reduces noise and volatility. And then with the standard deviation, which for something like this, it by definition has none, because this side over here does not have that inflection point. However, a lot of TA uses mean and standard deviation, and so therefore using the incorrect metrics for a distribution, for example, this type of shit, mean and standard deviation, you're going to have a bad time using something that has like this for something that has this value. So that's why a lot of TA is basically it's very common for people to say basically oh, I'm right about 10 or 30% of the time. It's because they're not using the correct distribution to describe the data set and how it's occurring. Instead, it uses this for ease, but this is not the right distribution to describe something like this. So you're going to inherently be wrong very often, because the mean is being pulled further out than what the most commonly occurring values are. Using the mean, you're only looking at the amount of data that exists here, versus the median shows the most frequently occurring value for that system. So it'd be better to use the median, which is the most common occurring, the middle number of the data set, versus the mean, because this mean, again, is not a good representation of the frequency of values that exist within the specific type of share price. When in all reality, this has a higher probability of existing because the majority of data is located right there. Water. Continuing on, why it's important to look at raw data is something that is unique to, GameStop, because that's all I live my life off of. So you have this type crap, whatever. And so because the superficial look of kind of blindly placing these lines without further analyzing what the fuck is going on here, there was a common occurring mistake to not look at the volume itself. So in theory, since the stock market is an emotional type environment, either there's going to be a natural buildup that occurs in volume. It's going to feel like, oh, a lot of people invested here or here and here for trading volume. Because, I mean, not all the entire population of retail investors are like, oh, we're going to invest exactly on this date. No, what happens is they invest in a range of dates. However, so one thing as to why I know something systemic is occurring, because there are these huge outliers that occur on one day, while the remaining ones are very small. There's no natural buildup. It is just like, bam. It all occurs on one day. And so this would indicate to me that retail has no influence, because something is occurring that is causing like an outlier volume to occur on one day. And not only is the outlier volume occurring on one day, which shows it has no natural growth to like overall, the dates of these outlier volumes repeat as well. In regards to like, I don't know, so August, November, then it goes to January. So without looking at the volume itself, which is another factor that in theory should like describe this crap, you wouldn't necessarily recognize how these huge, like improbable volumes, like the value, are occurring at frequent dates, because no one's looking into it. They're only looking into the time and share price and randomly placing these lines that are discrete with values that are occurring above and below it. And so I mean, there have been a litany of TA to be like, oh, shit's going to happen tomorrow or next week or whatever. All of it's been fucking wrong. Because a lot of it is randomly placed stuff that makes sense to the person who did it. And then all the people just kind of roll with it because they have confirmational bias and they want to see that shit actually happen. So therefore they ignore any other possibilities because they want this shit to happen so much they disbelieve anything else that's going to occur. So confirmational bias, that's going to happen. Oh my gosh. So I'm going to finish up here because I extended this far longer than I thought it would. If you use the actual data set or distribution that is shown with the data set, you'll have a higher probability of being able to calculate what's going to happen. This is more likely to occur if you actually look at the raw data versus drawing lines randomly. Because looking at the raw data, you can perform the actual analysis. You'll be able to see like, hey, this isn't a normal curve, and that's why the median doesn't equal mean. Looking at the raw data will tell you so much more than creating visuals on a chart and making assumptions. You'll be able to calculate the correlation or probability of something occurring and be able to place, identify where like unique characteristics occur, like, or these outliers occur. You'll be able to like actually see where the fuck they're happening versus being prone to observational bias. Anyways, that has been a fuck ton long of talking and my throat hurts. Anyways, my name is Pone with a fuck barbecue. Please say it's Pone, it's not Pawn. It is elite language for player owned. Pone with a fuck barbecue. I guess let me end this with it is Counter Day. Take care of yourself. There's only one of you, so don't be too obsessed about all this crap. Self-care is important. I mean, yeah, they take good care of yourself. There's only one of you. So with that being said, keep your hands diamonds.